So, hello everyone. When I learned to do style, someone told me you need to start with a joke because like it's kind of break the ice. But my wife always told me I always only do bad jokes, so I decided to put a nervous joke in my presentation. So I'm sure it's not too bad. We still got time to read. So here we go. I'm at Provencher. What could be interesting to know about me, I'm the president of Montreal Authority, or Montreal Area. So our new name is Montreal Authority. It's the same kind of the Python Montreal community, but for Ruby as a similar language that have their own difference, but it's mainly the same thing. And I'm working at Hopper. Hopper is a company that is trying to do a search engine for travel, so you type stuff in it like beaches in Spain, and you get all the best beaches that are in Spain, ranked by like the most, the destination you would like the most to get there because it's cheaper and it's fun to go. Rank first and go through like all of them. So today I won't explain you Ruby like Yannick explained you Python. What I will tell you is like a story how you can design an application that could make you rich if you want to. But it's not why we design it. It's because we're tired of waiting about how Facebook, Twitter, Reddit, and Hacker News because they're all social media, and each day when I want to see them, I start my day, I go on Facebook, after I go on Twitter, after I go on Hacker News, and after you go on Reddit or anyone else that you go, and it's really long to go after one each of the other. So what we do is just create an application that will fetch all the data that you want on all of those sites and bring it in your application. That's not really hard to do because they give you APIs to be able to do it. So our first design would be that. So that's what we build our UI application. That's the TechnoTalks website if you want to recognize it. And the strange logo at the top would be all the social medias. Maybe I would call them really often Twitter because it's the one that I work the most with. But that's kind of how it works. Like when you connect on your web application, it fetches the social media to get like your tweets or your Facebook wall posts. It gets back to your application and you are able to display them. And the arrow on the other end is just be able to, so you can say, I read that tweet, I want to answer, so your application is able to answer back. So it's not like you don't do that in one day, but it's not that hard to do. So you have your application, it's cute, it's really nice, or it can be pretty, depending on what you want. So, but you have one main problem right now. Is like if you want to save your tweets from yesterday, you cannot because you need to fetch all of them back on Twitter. So in our current architecture, you need to have a database right here. Database, you can see that like a file in your Windows file system or any OS that you are using. So what you do, you get your tweets from Twitter and you save it on the database. And next time you want to show your tweets from yesterday, you go see your database and on Twitter. It's a lot faster and it's more fun to do. But that's slow, because you need to remember that a web interface is an event-driven application. So it only do something when someone connects on it. So every time you connect, you need to fetch all your information for the current day. It's pretty long to do. So instead of that, we create a backend application. That's a big step. So what? We change everything. So that's the application that is responsible to fetch your Facebook, Twitter, Hacker News, and Reddit information. That's because it's what it's doing, and you can do that in real time because it's an event-driven application. So that's why you have the link, you have the same link with the social media, and because we already have it, we just continue to use the database as a way to pass message between the two applications. So when you want to get a tweet, you send it to the database, and the backend read it from the database and delete the entrance and the entry and just get what you want and save it back to the database. But it's cool, but you're like 1 hour late because you poll Twitter every hour because you want to know at each hour what are your new tweets. But your friend just told you, hey, I got that new stuff really cool, it was 15 minutes ago. You say, yeah, so I can change my 1 hour delay to 15 minutes. But If it's even 15 minutes, it's still long. What you can do, you can change it for 5 seconds to be a faster. But if you always ask your Twitter, give me my new tweets, give me my new tweets, give me my new tweets, Twitter will just say, shut up, and they will just cut your connection, so you won't have anything. So what you use the streaming API, which will be the line here. So a streaming API is Twitter, it knows when you get a new message. So instead of you asking for your new message, Twitter will send you that message directly. So you don't have to just always verify if your account is up to date or not. So that's a big advantage. So now you have your real-time application. That's nice, it's working. So you talk to your friends about it. You talk to your friends about it, to their friends about it, to their friends, and you understand what is going on. So again, too much people on your website, because you cannot do that for everybody. Because you're forced away, because your database is added to overrun. If you do something with it that is not done to do it, you push message through your database. In software, we have something that is done for that. We call that a queue. You can see at the top. A queue respect a FIFO implementation normally. That means first in, first out. So if you enter 1, 2, 3, 4 in the queue, you will, when you really read it, you will want to read 1, 2, 3, 4. So it's really easy to do. So like if from here you ask, I want to register a new user, get his tweet and his Facebook. So from the queue, your backend will receive an order, I want to register a user, get the tweets and get his Facebook wall post. So that's pretty cool. You have an application that can scale and you can without your user, but you start to be pretty big. That's a lot of people are using your application. So you have a marketing team now. That's nice. And I tell you, we have that killer feature, the feature that everyone will want to use. And it's really nice. And you say, good. That's great. I want to use that feature. It's really nice, but you need to do a lot of CPU to be able to run it. So the application is slow. Again, it's always slow for application when you have too much user. Because what you do, every time you want to get to run that feature, you need to spend like 2 seconds to calculate all your data. It's really too long. So we'll do a big modification of our architecture. We'll put everything in our backend application. That means we'll be responsible to do everything except the UI. The UI will be the only part that will still be the UI that user will interact with. But instead of using a queue in a database, you will always ask the backend for everything that you need. If it's like the tweets 1 to 10 from one person, or it's Facebook wall posts or anything, you only always ask for the backend. Because when you are in the backend, you can know if someone asks you for the 1 to 10 tweets. Normally we'll ask for the 1 to 10 Facebook wall posts right after, so we can pre-fetch it. So when he will ask it to you, it will be all in the RAM and you'll be able to give it really quick. So that's why the UI don't have any database anymore, because the backend is using it, so it's intern. So your UI don't even know that you have a database. The queue, because it was already in our architecture, we didn't remove it. So since we are using it, we don't remove it, but it's not forced to be there. And the social medias, if you don't have them, you don't really have an application. So that's cool. After our marketing team came back again and said, hey, we have a lot of information, or we have a lot of users, we can sell this information to this company who will be interested. And at the same time, we have a wiki company that just wants to grab our UI and put it in our interface. It will give us millions to do that. And you say, great, no problem. We will be rich. That's really cool. Here, do you see what I've done? I just do an external name for the APIs. You already implemented it. You have that in your own UI, or your own UI, so you can change that for anything. It could be an external company or anything. That's probably how Twitter is doing. Like they use their own API to display the Twitter website. So if you want to get stuff from Twitter, you use exactly the same APIs that what they have. So that's nice. So that's the end of our journey, I think, because we have our fast application that can have a lot of users. You can prefetch everything in the backend. So you are live, so you're happy with your application. But you can tell me, since the start, we had only one UI, and now you have a lot of stuff and everything, you push everything through the backend at each step. That's true. So you can ask me, how can you design the backend? So pretty simple. That's probably will be an high view of how your backend will work. So if we get there, you have your entry from your API, what the other people view or your own UI. If you need to read data from your database, you have a direct link. When you can cache stuff here, you can be able to render them quicker. If you need to push like a tweets or a Facebook wall post, you go through the queue, and you have an application that is done only to do that. So when you have something in the queue that needs to be pushed on a social media, your sender will just get the message and send what is needed. So that's okay. On the other hand, that's the string line that we have from the social media. So we have an external application, another application that's called a parser. The only thing that it does is receive the message, parse it to put it in the standard way, because we will have a parser for Facebook, a parser for Twitter, a parser for Reddit. So since you will have all those parsers, well, you will just grab them and put them to the queue with a standard way to be there, because you don't want to manage to do too much calculation on that side, because if you're too slow on your parsers, Twitter and Facebook will stop sending you messages because you will slow them down. So you need to be really quick on that part. So after you put that on the queue again, the analyzer will just get the common message that if it's coming from Facebook on Twitter, and we'll be able to do the calculation you need and save that to the database with the APIs and connect to it. That big advantages of doing that is you can scale it horizontally. So that means that if you have like one parser and you have 2 times too much message that's coming from Twitter, only the thing that you need to do is boot a second parser right behind it. So since both of them will read from the queue, and remember a queue is the first in, first out. So the first application will read the first message, and the second application will read the second message. The first application will read the third message, and the second will read the fourth message, and it will continue like that until we don't have any more message in the queue. If it's too slow, you can add 2, 4, 10, 1,000 new parsers. Don't really care, because your new bottleneck will be your queue just here. But a queue implementation, they are usually really quick, and it shouldn't cause you too much problem. So it should be okay. That's pretty much what I had to say today. That's all the picture that I used for my presentation. I just want to thank the people that have done it on the freedigitalphotos.net, because without them I won't be able to do all those pictures, and though I'm not that good in drawing. So, conclusion. That's the 7 steps that you get through. They are not like, you can consider these 2 to be equal, but if you want to do that kind of application, there is steps that you really need to do, because you won't do all those steps because they're not really useful. We start with that one. If you want to do really a simple application, only like a UI, a database, and the social media will be enough. If you need to really scale it because you have a lot of users or you want a lot more speed, we'll go with the queue interface beside the database. Because you will see, just adding a queue instead of doing it by the database will be a lot faster. If you want to add a backend, add a queue. That's pretty much the rule. And on the other hand, the API, it's really when you really need it. Like when you have really big CPU bound calculation to do, and if you want to just sell your API to someone else. In that case, you need an API, so or it won't be really useful. And to finish, I could tell you that design is for that problem. You don't have an universal solution for all the problems we get in software engineering. So that's why we have our job. Every problem need to have its own solution. So don't copy that design everywhere. Thank you very much. Do you have any questions? Yeah.
Can you talk about a little bit what you guys do with Ruby, like the Ruby user group? I know that Janine talked about Python.
Yeah.
So what you guys do?
We do, like, we are a little less than what Python is, but it's not like the same age category too. I think that's our main difference on our events. Our events is more like we meet every third Tuesday of each month. And we meet at Nutman House normally. We have like 40 person in average. And it's normally 2 talks. And after it, we go drink a beer with the other people to do networking, know about our projects, and do stuff like that. So if you want to come, you're all welcome. It's free and it's for everyone. You don't need to be everybody for to come. If you have any question about the language or anything, you just need to be there and someone will answer it. The guys there are really cool. Yeah.
So this architecture, have you implemented something like that? And so what kind of workload of coding work can we expect to get something like that?
I've done that architecture when I was at Theater.
Okay.
Theater was my company that I created in March. That was dead 3 months later. Died 3 months later. So, but we implemented that with the backend design that I show you, and we start from nothing, and by knowing how to work with Twitter, Facebook, solving other marketing problems and stuff like that. In like 2 months, we were over at 2 developers using Ruby. So we were using Rails for the UI, we were using JRuby for everything that was in the backend. JRuby is the Ruby language implemented in Java, so it's running on the Java virtual machine. The advantage of that is that if you want to use a Java library, you are able because you are running the same environment as Java.
So for JRuby, so in Python we also have JPython, but the advantage is not that great because there are really few Java libraries for which there is no Python equivalent. There is an advantage if you're using a big application framework like Tomcat that is already half implemented because you're connecting to an existing system. So in your case, starting from scratch, what was the advantage of going with JRuby?
We had some problem with some Ruby library, like the HTTP library, the library that you use to get information on a website. Because our goal was to fetch Twitter, for example, and we get all the links that we could on it, and we were fetching the page to get information on them. So that library was some broken feature in it, and it was slower than the Java library. And at the same time, we have the global interpreter lock in Ruby. That means that you can only run one thread at a time in Ruby. When you use JRuby, you don't have that lock, so you can run multiple threads. That means you can run multiple parts of your application at the same time. So you use like your quad cores as a quad core. So that's because that's the limitation that we have with the current version of Ruby.
Cool.
There was one, like I understand like speed is of the essence here. And there was one part you were talking about, you mentioned 2 seconds, and that seemed like a crazy, crazy long time. And I forget about it was the database.
I told it before we went to that step. But imagine that you have a database with 2 billion entries in it, and you need to filter them and join them with another table that have 2 million entries with it. So if the time that the database search and parse everything, you can get easy to
The
say.
databases are quite actually very big. So the databases are very big actually.
I didn't hear.
The databases are reasonably big.
Yeah, that means like if you do a normal application, you will never care about that. Like when you use Ruby or Python, if you do like normal application, like most of the time you see, you won't have any problem usually. If you like doing application that run on 10,000 servers and stuff like that because it's well distributed, at that time you get an advantage to go and see a faster language. That will be longer to implement, and less fun at the same time. But at that time, you can get advantages of that. But when you don't do big data with like what I present right now, it's really, you don't have that kind of problem normally. That's why I say that normally websites are based on that structure normally. And if you really need to do scale, that one will do your job like 95, 99% of the time. You need more speed.
I noticed that both of you have backgrounds with search engines, and is that a good way for entering into?
My current job is search engine, but it's my last job in my role. That's what I do currently.
Yeah.
but I don't think, I think any job, personally I really like to do startups companies, because it's kind of like you can do more than just one thing. When you go in like bigger companies, you're often forced to do like, you have one task that you need to do, so you have to do that. So when you are another, like in my first job, I was doing C, C++, Ruby, electric design, and marketing. I was doing like everything. I was doing installation on the client side at the same time. So you change your mind often, so you are able to learn other stuff. I really like that.
I would say that doing the user part of a search engine is kind of boring because it's already done and you have performance constraints and things like that. But writing the crawler, that's something that I really like, because doing data mining, being able to transform boring, unusable, user-presented data into data that you can get statistics out of, that you can learn from, that's something that I really like. It lets you open the hood of all of these websites and see, oh, that's how they do their HTML. Okay, I'm going to get the data, but also I'm learning from that. And I think that writing a web crawler is a very good learning experience.
Yeah.
How about Hopper's web crawling? How do you see that would work, or how does it work?
Upper use something is similar, but most of Upper is done in the back end. Like more, Upper is done on that structure. Upper parts all Wikipedias, and I think we have like 30,000 generators or something like that, and it's more. And each of those crawl a certain part of the web. So we have a lot of web pages that we crawl and get information out of it. And we use MapReduce to do that. So MapReduce is another technology that we talk today. It's not recommended. It was developed by Google. It was developed by Google at the start. It's an easy way to like distribute. We are building like 1,000 nodes. I think I just threw numbers everywhere, but we're building like our own cloud in Montreal in our office to be able to run our codes. That's what we are doing right now. And we use that cloud to parse the web, to crawl the web.
You mentioned that you like to work with startups.
Yeah.
And I know you're working for Hopper right now. And I see that you're also moving to Cambridge, you're expanding. So how do you see this transformation going, like, to be just from Montreal to the Montreal and Cambridge? So how do you see Hopper going that way? What do you see is going to happen soon with Hopper? It's going to be like a big corporation like Google, or?
If Hopper is going to be a big corporation like Google, no, because the Hopper product is still beta. It's not open now. It's not public, so we cannot use it. So Hopper is still in R&D. We are still doing research and getting stuff like harder. We do like we have a lot of bar to break before we're able to launch our product. That's why it won't be like next Google tomorrow. It would take some years, some months. Or I don't know how much time. Depends on which bar we're going to face. But that means at the same time that every problem that we get and we solve, if someone else wants to try to do the same thing as us, they will need to get through the same problem. So we still have an advantage over them because we start earlier.
I was just wondering, you mentioned that you were using a cloud to crawl, so I was just wondering how you were synchronizing the different computers together. Do you use a special layer, a special program, like an API or something like that, to get them to talk together and share the messages?
To answer your question, the layer is called MapReduce. That's the technology based on, and we use technologies that are based on multi-servers. So every technology, if you go about Cassandra and MapReduce, I think Cassandra is based on MapReduce, but it's always distributed. We cannot do anything on Hopper that it cannot be run on 10,000 servers at the same time. It needs to be distributed, or we will never stop making our computers work. Any more questions?